Last year, telescopes around the world registered the brightest cosmic explosion of all time. Astrophysicists can now explain what made it so dazzling.
This is the Scienzz, and you are watching Decoding the Mystery of the Universe's Brightest Explosion GRB 221009A.
During a GRB, meaning a gamma-ray burst, we see the death of a massive star, approximately 30 times more massive than the Sun, and the formation of a black hole. The black hole launches a very fast jet close to the speed of light, and the jet will produce a gamma-ray burst. At later times, GRBs are visible at other wavelengths as well, from radio or optical through very high-energy gamma rays, which is called the afterglow of the GRB. This GRB was so bright, the afterglow showed up in the gamma-ray burst monitor, which is very uncommon, and we could follow it for almost 3 hours. Astronomers think GRB 221009A represents the birth of a new black hole formed within the heart of a collapsing star. This advanced GBM, operated by the University of Alabama, continuously scans the sky for incoming GRB's light. According to the release, the GBM has 12 sophisticated detectors to achieve this goal. A few of its detectors are made of sodium iodide and designed to detect X-rays and low-energy gamma rays, while 2 are made of bismuth germanate to look at high-energy gamma rays. The crystals within the detector light up whenever gamma rays interact with them. The more energy in the burst, the more light is generated. The GBM can determine the direction of the burst by seeing which crystals light up. The Fermi telescope has detected over 3,500 GRBs, with 221009A being by far the brightest. This gamma-ray burst was extremely bright. We expect to see one like this only every 10,000 years or so. Few cosmic explosions have attracted as much attention from space scientists as the one recorded on October 22nd last year and aptly named the brightest of all time, BOAT. The event, produced by the collapse of a highly massive star and the subsequent birth of a black hole, was witnessed as an immensely bright flash of gamma rays followed by a slow-fading afterglow of light across frequencies. Since picking up the both signals simultaneously on their giant telescopes, astrophysicists the world over have been scrambling to account for the brightness of the gamma-ray burst, GRB, and the curiously slow fade of its afterglow. Now an international team that includes Dr. Hendrik van Erten from the Department of Physics at the University of Bath in the UK has formulated an explanation. The initial burst, known as GRB 221009A, was angled directly at Earth, and it also dragged along an unusually large amount of stellar material in its wake. Dr. van Erten, who co-led the theoretical analysis of the afterglow, said, "Other researchers working on this puzzle have also come to the conclusion that the jet was pointed directly at us, much like a garden hose angled to spray straight at you, and this definitely goes some way to explain why it was seen so brightly." But what remained a puzzle was that the edges of the jet could not be seen at all. The slow fade of the afterglow is not characteristic of a narrow jet of gas, and knowing this made us suspect there was an additional reason for the intensity of the explosion, and our mathematical models have borne this out. Our work clearly shows that the GRB had a unique structure, with observations gradually revealing a narrow jet embedded within a wider gas outflow where an isolated jet would normally be expected. So what made this GRB wider than normal? The researchers have a theory. As Dr. van Erten explained, GRB jets need to go through the collapsing star in which they are formed, and what we think made the difference, in this case, was the amount of mixing that happened between the stellar material and the jet, such that shock-heated gas kept appearing in our line of sight all the way up to the point that any characteristic jet signature would have been lost in the overall emission from the afterglow. He added, "Our model helps not just to understand the BOAT, but also previous brightness record holders that had astronomers mystified about their lack of jet signature. These GRBs, like other GRBs, must be directed straight toward us when they happen, as it would be unphysical for that much energy to be expelled in all directions at once. An exceptional class of events appears to exist that are both extreme and manage to mask the directed nature of their gas flow. Future study into the magnetic fields that launch the jet and into the massive stars that host them should help reveal why these GRBs are so rare. Dr. O'Connor said, "The exceptionally long GRB 221009A is the brightest GRB ever recorded, and its afterglow is smashing all records at all wavelengths. Because this burst is so bright and also nearby, cosmically speaking, it occurred at the minor distance of 2.4 billion light-years from Earth. We think this is a once-in-a-thousand-year opportunity to address some of the most fundamental questions regarding these explosions, from the formation of black holes to tests of dark matter models." Thank you for connecting with us. Don't forget to subscribe to watch more such informative content.